Ever pondered about what lies beyond our world and the threats it could possibly pose to us? As we gaze into the star-studded canvas of the night, it's easy to forget that the universe is not just a spectacle of beauty, but also a realm of mysteries and potential dangers. Our understanding of the cosmos has grown by leaps and bounds, but it's still a drop in the cosmic ocean. The universe is vast and largely unexplored, and with its grandeur comes uncertainty. What threats could be lurking in the shadows of the cosmos? Could a rogue planet be on a collision course with Earth, or perhaps a supernova's deadly radiation is headed our way? Could there be alien life forms plotting an invasion? Understanding these cosmic threats is not just about satisfying our curiosity, but it's also about survival. It's about preparing ourselves for what's out there. So, without further ado, let's dive into the top 10 cosmic threats to humanity, starting from the least dangerous. Starting at number 10, we have solar flares. Imagine the sun having a bad day and throwing a tantrum. In essence, that's what a solar flare is, a magnetic explosion on the sun's surface. These flares release a burst of radiation across the entire electromagnetic spectrum, from radio waves to X-rays and gamma rays. While most of this energy is absorbed by our atmosphere, a particularly strong flare can disrupt satellite communications, interfere with GPS navigation, and even cause power outages. This isn't a theoretical threat either. We have historical evidence of a solar flare's potential for chaos. Let's rewind to the late summer of 1859. The sun belched out an enormous solar flare, now known as the Carrington event. The electromagnetic storm was so powerful that telegraph systems across Europe and North America went haywire. Sparks leapt from telegraph machines, shocking operators and even setting papers on fire. Now consider our modern, technologically dependent society. Our reliance on satellite communications and power grids is far greater than the 19th century reliance on telegraph systems. If a solar flare of the Carrington event's magnitude were to occur today, it could wreak havoc on a global scale. To put it into perspective, a study from the U.S. National Academy of Sciences suggests such a flare could cause up to $2 trillion in damage in the United States alone and take up to 10 years to fully recover. A massive solar flare, although unlikely, could disrupt our technology-dependent lives. At number 9, we have asteroids and meteorites. Let's take a moment to consider the celestial bodies whirling through space, asteroids and meteorites, whose paths may at any time intersect with our own. These cosmic stones, some as small as a grain of sand, others as large as mountains, are remnants from the dawn of our solar system, over 4.5 billion years ago. Now imagine one of these behemoths streaking across the sky, a fiery tail in its wake, hurtling towards Earth. Sounds like something out of a science fiction movie, right? But this isn't fiction, this is a potential reality. Take a step back in time, around 65 million years ago. The dinosaurs, the reigning champions of Earth, were abruptly dethroned when a chunk of rock 6 miles wide slammed into what is now the Yucatan Peninsula. The impact released energy equivalent to 1 billion Hiroshima bombs, causing a mass extinction event. Fast forward to today, and we find ourselves in the firing line of these cosmic bullets. Don't worry too much, the odds of a similar event happening in our lifetime are low. But even a small meteorite can cause significant damage, as was seen in Chelyabinsk, Russia, in 2013. So while the chances of a catastrophic event are slim, the potential devastation is quite literally out of this world. The probability is low, but the potential damage is astronomical. Moving to number 8, we encounter supernovae. What are supernovae, you ask? Well, in the simplest terms, a supernova is the explosive death of a star, and it's not a quiet exit. When a star at least 5 times the mass of our Sun exhausts its nuclear fuel, it collapses under its own gravity and then explodes, releasing an incredible amount of energy. This explosion can outshine an entire galaxy for weeks or even months. Yet how could this stellar swan song pose a threat to our humble home? The danger lies in the aftermath of the explosion. A supernova can produce gamma-ray bursts, the most energetic form of light. If a gamma-ray burst were to hit Earth, it could deplete our ozone layer, exposing us to harmful solar radiation. But don't pack your bags just yet. For a supernova to pose a significant threat, it would need to occur within a few dozen light-years of Earth. The closest star to us that could go supernova is Betelgeuse, which is about 600 light-years away. To put that into perspective, if Betelgeuse exploded tomorrow, we'd have to wait 6 centuries to see the fireworks. So far, no supernova event has been close enough to affect Earth, but the universe is full of surprises. And while we're safe for now, it's a reminder of the powerful and potentially deadly forces at play in the cosmos. At number 7, we have the terrifying black holes. Black holes, the enigmatic monsters of the cosmos, are areas of space-time exhibiting gravitational acceleration so strong that nothing, not even particles or electromagnetic radiation such as light, can escape from it. The term black hole is fitting due to this complete absorption of light and the subsequent visual blackness. Born from the remnants of massive stars after they collapse under the weight of their own gravity, black holes are incredibly dense. Picture this: a black hole with the mass of our sun would be roughly 6 miles across. That's about the size of a small town. Now imagine a black hole passing close to our solar system. The gravitational pull could fling Earth out of the sun's orbit or suck us into a spiraling death dance. Either way, it wouldn't be a pretty sight. However, the likelihood of a black hole getting close enough to cause such chaos is extremely low, but the very existence of these cosmic beasts serves as a reminder of the immense and sometimes terrifying forces that govern our universe. It's not just the destructive potential that makes black holes fascinating, but also their mysterious nature. They are key to understanding the fundamental laws of physics, yet they remain cloaked in mystery, their secrets locked behind the infamous event horizon from which nothing can escape, not even light. Black holes remain one of the most mysterious and terrifying objects in the cosmos. Number 6 brings us the possibility of an alien invasion. Now hold on to your space helmets, folks. We're delving into the realm of the unknown, the uncanny, the extraterrestrial. Picture this: a universe teeming with life, a cosmic playground filled with countless civilizations, each more diverse and technologically advanced than the last. Now imagine, if you will, these civilizations, curious and explorative, venturing out into the vast expanse of the cosmos, crossing the chasm of light years to reach us here on Earth. The question isn't whether these civilizations exist. The real question is, what are their intentions? Are they peaceful explorers seeking to share knowledge and foster cosmic unity? Or do they harbor darker motives, viewing our blue planet as a resource to be exploited, a world to conquer? The potential for an alien invasion is a fascinating, albeit unnerving possibility that we must consider as we gaze up at the stars. While we have yet to encounter extraterrestrial life, the absence of evidence is not evidence of absence. The universe is a vast place, and we're still just scratching the surface of what's out there. As we continue to probe the cosmos, we must also prepare for the possibility that we are not alone, and that the beings sharing our universe may not come in peace. The truth is out there, and it may not always be friendly. At number 5, we find rogue planets. These celestial nomads wander around the cosmos, unattached to any particular star system. Unlike the planets in our solar system that follow a predictable path around the sun, rogue planets have no such tether. They are the wanderers of the universe, moving about in seemingly random patterns. Rogue planets are typically ejected from their original star system, sent off on a cosmic journey by gravitational disturbances. Imagine, if you will, a planet several times larger than Jupiter, moving through space at incredible speeds. Now consider the catastrophic event that would occur if such a planet were to collide with Earth. The impact would be beyond anything humanity has ever witnessed. The energy released would be enough to vaporize the Earth's crust, sending shockwaves that would ripple through our entire planet. The aftermath would be a world unrecognizable, a planet left charred and barren. But before we surrender to cosmic fear, let's remember that the odds of such a collision are astronomically low. Space is vast, and even though there are potentially billions of these rogue planets wandering through our galaxy, the chances of one crossing paths with Earth are incredibly small. Rogue planets remind us that our cosmic neighborhood is constantly changing. They serve as a reminder of the dynamism of the universe and the ever-present, though minute, risks that come with living on a planet in an ever-changing cosmos. Number 4 brings us to the theoretical threat of vacuum decay. Now you might be thinking, what on Earth, or rather in the universe, is vacuum decay? Well, in simple terms, it's like the universe having a catastrophic existential crisis. In the field of quantum physics, the vacuum we think of as empty space isn't exactly empty. It's filled with what we call quantum fields, and our universe is thought to exist in a stable state within these fields. But what if our universe is actually in a false vacuum, a sort of temporary unstable state? That's where vacuum decay comes in. It's the theory that a random quantum event, or even just a high-energy particle, could trigger a shift from this false vacuum to a true vacuum. And this wouldn't be a gentle shift, no. It would be more like an ultra-fast, destructive bubble expanding at the speed of light. Let's be clear, if such a bubble were to form, we wouldn't see it coming. There would be no warning, no time to brace ourselves. One moment we'd be here, and the next, poof, we simply wouldn't exist anymore. The good news? It's all purely theoretical. Scientists have no evidence that such a shift is likely or even possible, but it does remind us of how little we truly know about the universe. Vacuum decay, however theoretical, could mean the end of everything. At number 3, we have the Big Crunch. Picture this: everything that has ever existed, all matter, all energy, all space and time, compressed back into an infinitesimally small point. This is the essence of the Big Crunch theory, a hypothetical scenario for the ultimate fate of the universe. Now, you might be wondering, how could this possibly happen? Well, the answer lies in gravity. As we know, gravity pulls things together, and right now, the universe is expanding. But if gravity were to overcome this expansion, it could cause the universe to collapse back in on itself. This process wouldn't be quick. Oh, no, it would take billions upon billions of years. And as it happens, galaxies, stars, planets, and eventually all matter would be drawn closer and closer together. The distances between cosmic objects would shrink until everything is pulled into a singularity, a point of infinite density. This is the Big Crunch, a fiery, chaotic end to everything we know. But remember, this is just a theory. There are other theories out there like the Big Freeze and the Big Rip, each with their own unique set of circumstances leading to the end of the universe. Despite the grim outlook, these theories are not reasons for despair, but rather they are reminders of the vast, complex, and ever-changing nature of our universe. So the next time you look up at the night sky, remember, the Big Crunch could be the final act of our universe. Coming in at number 2 is the Big Rip. This is not your average run-of-the-mill cosmic threat. This is the big one, the granddaddy of them all. The Big Rip is a theoretical cosmological model, a hypothesis about the ultimate fate of the universe, and it's as terrifying as it sounds. Picture this: the universe, which has been expanding ever since the Big Bang, continues to do so, but at an ever-increasing rate. Now, this isn't just galaxies drifting apart. We're talking about a force so powerful that it tears apart everything in its path. Galaxies, solar systems, planets, right down to the smallest atoms. Nothing would be safe. So what's the driving force behind this? Dark energy, this mysterious form of energy, which makes up about 70% of the universe, is believed to be the cause of this accelerated expansion. And if its strength continues to increase over time, it could eventually overwhelm the forces that hold matter together. Of course, this is all theoretical. Scientists still have a lot to learn about dark energy and the nature of the universe itself, but the Big Rip represents a possible, albeit terrifying, end to everything we know, a cosmic threat on a scale that's hard to comprehend. Remember, though, that these cosmic threats are not meant to incite fear, but rather to inspire awe at the vastness and complexity of our universe. The Big Rip is a cosmic threat on an unimaginable scale. And the number one cosmic threat to humanity is the heat death of the universe. Imagine a future so distant that it's beyond human comprehension. We're talking about a timeline that's measured not in centuries, not in millennia, but in trillions of years. This is when a chilling cosmic event could occur, known as the heat death of the universe. The heat death theory is based on the second law of thermodynamics, which says that in a closed system, entropy or disorder always increases. Now, apply this to the entire universe. As stars burn out and galaxies drift apart, the universe will become a uniformly cold, desolate place. But how could this happen? Well, energy is constantly being transferred from hotter objects to colder ones. Over vast cosmic timescales, this could lead to a state where all energy is spread out evenly. When this happens, there would be no more room for energy to flow, no more heat differences, and therefore no more work that can be done. In essence, the universe would experience a sort of thermodynamic equilibrium, no stars shining, no planets forming, just a dark, silent, and incredibly cold universe. What does this mean for us? Well, Earth and humanity will likely be long gone before this happens, but it's a sobering thought. The universe, the stage for all existence, could one day become an empty theater. The heat death of the universe could be the inevitable end we all face. So there you have it, the top 10 cosmic threats to humanity. From the fiery fury of solar flares to the destructive potential of asteroids and meteorites. From the explosive power of supernovae and the enigmatic nature of black holes to the chilling thought of an alien invasion or the unpredictable path of rogue planets. We've delved into the terrifying concept of vacuum decay, the universe shattering Big Crunch, the universe tearing Big Rip, and the inevitable, yet unsettling heat death of the universe. Each of these threats underscores the immense and often unfathomable forces at play in our universe. They remind us of our place in the cosmos, not as masters, but as humble observers and explorers. As we continue our journey through space-time, understanding these threats is not just fascinating, it's crucial. Remember, the universe is vast and full of mysteries. Let's keep exploring, stay curious, and always look up.